Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. In this video, we will discuss question number 14 and question number 15. For question number 14, they give you a diagram, a circuit that consists of resistor, inductor and capacitor. So over there, they give you the values of voltage across each component. Okay, by using the facet diagram, find the supply voltage and the phase angle between the supply voltage current in the circuit. So the keyword here is that you have to use the facet diagram. So I already draw the facet diagram. So by now I think you guys should remember kot langit, cacing and rumah over there. So this is just basically from the information that I gathered from the question itself. Okay, now you will expect the VRMS to be somewhere over here. Okay, how do I know that? Is that I can bring the VC up here, so it will be VL minus VC. So I might get some vector over there and VR is over there, so VRMS somewhere over there. So I'm going to draw it again. Now maybe I can minus VL with VC. Okay, so the VR stay the same. Okay, so this is my IRMS. Okay, this is my VL minus VC, and this would be my VR. Okay, so from here to here, from up here to down here, what I did is that I bring the VC, I flip the VC. So if you flip, you have to take negative. So that's why this one becomes VL minus VC. Why I didn't flip VL to VC? Because I can see that this number is bigger than that one. So by logic, you will expect VRMS over there lah. That one just a simple logic. Okay, so here I can draw my VRMS maybe somewhere over there. The first question they want to find supply voltage, which is the VRMS and the phase angle. So maybe I can write over here V supply is basically my VRMS. So based on my facet diagram, I can find my VRMS using Pythagoras, which is VLC square plus VR square. Sorry, VL minus VC square plus VR square. So this is my vector there and there. So A square plus B square, take the square root. So that means this one I can write. So basically this is the formula lah. Okay. So this one would be 141 square plus 327 minus 133. Okay. Sometimes they might give you in terms of resistance, reactance, capacitance and reactive inductance. But the concept still the same. You basically just apply in terms of reactance and resistance. Sama je. Okay, kalau dia kasih dalam tu lah. So this one you will get 239.83. Okay, this is your VRMS. And the question also want you to find the phase angle. So the question to find the angle over here, phi. Okay, again, basically, if you're referring to this diagram, it will be cos phi equals to adjacent over hypotenuse, which is VR divided by VRMS. Okay. So I think I'm going to draw it over here. So your phi is basically up cos. Again, double check what mode do you use in your calculator. So VR is equals to 141 divided by VRMS, which is 239.83. Obviously, you can approach this problem with different method, but this one is the method that I use. I think it's quite simple. So here I got 53.99. Don't forget to write the unit there. So if radian, you just use radian. But this time my calculator is in degree. Final answer will be in degree. Question B, calculate the values of current flows in the circuit if the resistance is 68 ohm. Okay, question B1, they give you now the values of resistance. Okay, if you look back at your facet diagram or in the question, they did give you VR. So I can partner VR with the R. So I can use equation VR equals to I RMS. So basically I is the same across the circuit R. So I RMS is equals to VR is 141 divided by 68. I got here is 2.07 ampere. Okay, that one is for B1. For B2, they want to calculate the inductance and capacitance given that the frequency is 50 Hz. So frequency is 50 Hz. And the question want to find capacitance and inductance. So don't confuse reactive capacitance with the capacitance itself. So if I want to start with capacitance, I can use the formula of VC equals to IXC, where inside XC I have this is IRMS. Inside XC is equals to 1 over 2 pi FC. So obviously I can find my C inside here. So VC is equals to 133 volt equals to IRMS, we call it just now, from B1 1 over, so maybe I can bring this one inside like this, 2 pi 50 and C. So just press your calculator. The C would be 4.95 times 10 negative 5 farad. Okay, now you have the value of capacitance. How about the inductance? So basically use the same concept. VL equals to I, the partner should be XL. So it will be VL that is equals to 327. So I think I'm going to write it over here. It's going to expand this one a little bit more. So IRMS XL is equals to 2 pi FL. So IRMS is 2.07. 2 pi 50 and L. So the L here would be equals to 0.503. Then the last part, they actually ask you to find the resonant frequency of the circuit. So once you have the value of L and C, you can use the formula of resonant frequency straight away, where Fr is equals to, so this one I think question B3, 1/2 pi square root of LC. So we already discussed on how to derive this equation, so I'm not going to go through that one again. So L 0.503, C is 4.95, so that one you will get Fr equals to 31.90. The unit would be Hertz. Okay, for question number 15, this is the last question of the tutorial. A heater coil with a resistance of 34 ohm is connected to a 240 volt AC source. Determine the average power used. So first question, they want you to find P average. And then the second question, they want to find maximum and minimum value of instantaneous power. So P max, P min. Okay. We saw the first question first, A. If you want to find P average, normally you can use P equals to I squared R, or you can use my best method would be always P equals to I squared R. Okay, so if you want to use I squared R, you can use that one. But if I want to use a different method, maybe I can use P equals to IV and I RMS V RMS. But remember, if I use I RMS V RMS, I have to put cos phi over here. Okay, this is one of the main mistakes that student did on the exams when it involves power equations. If you want to use I RMS V RMS, you have to include cos phi. Okay, if I squared R or I RMS VR, you don't have to include the cos phi. Okay, but here notice that this one is just a AC circuit with the resistor. So if I want to use cos phi, so it would be cos phi equals to R over Z. So if you have more than one component, obviously cos phi will have a values. I mean, it will be a different values other than one lah. But since the Z here is actually equals to R as well, so this one is basically R, you can cancel out this one and it becomes 1. So this one becomes 1. But be careful, this is the actual steps that you try to go through here. So to be safe, if you want to use the P average, I strongly suggest you to use VR or I squared R. Okay, but since this one is one component, biasanya student terlepas lah, selamat lah. I RMS you don't have, so maybe I can use V equals to IR. Again, this one because you don't have any values other than, you don't have any component other than R. If you have, then this one would be VRMS, IRMS, Z. So you have to be careful a little bit. Maybe I can write this one as VRMS. And this one is basically equals to VR as well, because you don't have any other component. So I don't have the I, so it will be VRMS divided by R. So this is just VRMS squared divided by R, which is 240 squared divided by the values of R, which is 34, then you will get 1694.12 watt. Okay, and then for the next question, question B, they want to find the maximum and minimum values of the instantaneous power. So if you are looking at the term instantaneous power, so normally you can calculate Pi equals to I with respect to time multiply V with respect to time. So obviously you have to include all the function with that comes with the I and V, but here notice that the question wants you to find the maximum and minimum values. Okay, so you will notice that this one actually will becomes I naught V naught P. Actually I can write this equation. Okay, maybe I can go back to this equation again. Okay, if the question just wanted to find instantaneous at a specific time, so you have to use this formula. But this one, they ask you to find the maximum and minimum values. So this would be I RMS, V RMS, cos phi. I just use the initial formula that I use over here. Okay, but again, this is just a circuit with the resistor. You can cancel out this one, becomes 1. So you're left with I RMS, V RMS. So you know that the formula for I RMS is basically I naught divided by square root of 2. And this is just V naught over square root of 2 V RMS, right? So P, this is just a P average. This is instant. So square root of 2 multiplied with square root of 2 is basically I naught V naught over 2. Okay, so I naught V naught, I can represent that one with my maximum, which is equals to 2 multiplied with P average. So here I got P max, or what I write here as P naught, 3388.24, and the unit will be in watt. Okay, so the P minimum is equals to 0 watt. Okay, so thank you.